All right. The following video is going to focus on how to create a homemade acid-base indicator, which will allow us to determine the concentration of acids and bases in a lot of commonly found home used items for cooking, cleaning, and things like that. Now, for the first part, in order to start out with this presentation, I'm going to first off create an acid-base indicator by grinding cabbage with water, and we're going to grind it for just a little bit. Okay, now what I've done in this case is that I've created an acid-base indicator in the form of grinded up cabbage and water, and basically what's going to happen is that the molecules in this red cabbage that I've grinded up are going to react with the acid or base concentration different substances to change its color, and these are the substances that we are going to be using. Well, the first major substance we're going to be using is hand sanitizer. We will have hand sanitizer being used. And in addition to hand sanitizer, we will also be using baking soda, which also has a very distinct color. We will also be using sugar with water, which has a distinct color. And then there is also going to be, we will use lemon juice. We will also use milk as the substance you're going to be testing. And we're also going to be using household bleach, which is a commonly used cleaning product. And we're also, in addition, we're also going to be using vinegar, which is another common household cleaning product and cooking product. And this is just regular water, tap water, which everyone drinks and bathes with. Also going to test it. And finally, we are also going to be testing baking soda. And the way we're going to test everything is we're going to add the cabbage or water combination that we have just made with it. Now, for the purpose of creating this cabbage water combination, we just ground up the cabbage and are now going to pour the cabbage water through the strainer, and it should make a very nice and convenient little base acid detector. It's rather crude and homemade, but what's important to keep in mind is that when it comes to industry, especially the health profession, or various environmental protection agencies, and food manufacturing or other industries that often use reagents which will react with acids and bases. The idea is that we'll detect the acids and bases by the distinct color changes that occur. And for this experiment, we're going to show how different household substances will yield a different color change once we add the cabbage water mixture that will react with the acid or base that is present in these household substances. Now, the first example of a household substance that we are going to be testing in this case is going to be bleach. You will notice that bleach has a very distinct color. This bleach is going to have a very distinct yellow color, and you'll see what happens when you add our acid-base detector to it. Now, as you'll note, when this bleach has an acid-base color added to it, it is going to turn a very distinct color in the form of yellow. Now, in addition to the bleach, you're also going to test out what happens when we add this reagent to the baking soda. And notice baking soda has a very clear color, and when we add our acid-base indicator, is going to turn a noticeably distinct blue color. And the next substance you're going to test is vinegar. Vinegar has a very clear color, and when we add the reagent, when we add our cabbage water acid-base indicator to the vinegar, you will note that the vinegar has a very distinct and reddish color, right? A rather pinkish color, what you can term as a cross between wheat red and pink.
Can you explain where the colors fall on the scale of acidity or basicity?
That is a very good question. When it comes to acidity and basicity, if a substance ranges from red to pink, red is very strong acid, and as the substance becomes less acidic, it's going to turn a pink color. And so vinegar is something of a moderate acid from a moderate to somewhat weak acid. But we're also going to see, hopefully today, what happens when you add our acid-base detector to a strong acid, because a strong acid should turn a very distinct red color, and you're going to see that theory when we add it to lemon juice. Now,
and blue is more of a base.
And blue is going to be very much a base color, and the extreme base color is going to be when it's yellow or semi-yellow. And notice when we added the reagent to the bleach turned very much a yellow type color. So yellow is a very strong base. And you will notice how the lemon juice has a very, very strong red color, whereas showing a very strong acid, whereas the vinegar showed a more weak acid because it had a pink type color. Now, the next thing we're going to try to do is see what happens when we're going to add the acid-base combination detector to the sugar. Notice the sugar has a very distinct color, and when we add this reagent to the sugar, a blue color is generally an indication of either neutrality, and the deeper blue it gets, the more base that the substance is going to get. Now, notice that the sugar is having very much a distinct blue color, and in addition to the sugar, you also had the baking soda, which turns a very distinct blue color. And hopefully, we're going to see a bit of a difference between the baking soda and the sugar. The difference being that baking soda is going to have more of a base color, and it's going to have a darker blue color as opposed to the sugar. But in this case, the differences between the baking soda and the sugar are not really all that noticeable. Now, notice when it comes to a strong base color, yellow or semi-yellow is the best indicator of a strong base color. This is what happens when you add our acid-base indicator to bleach. It's going to have a very much a yellow type base color, or a semi-yellow base color in this case. And the next substance that we are going to try to test out is the hand sanitizer. Notice hand sanitizer has something of a green type color, and you'll see what happens when we add our mixture to our acid-base cabbage water substance to the hand sanitizer. So the hand sanitizer is going to turn a somewhat purple color. That is going to indicate weak to a neutral base. We're going to see what happens when we stir up the hand sanitizer. Notice that basically, if a substance is purple, that indicates neutrality or close to neutrality. More of a darker blue color is going to indicate more of a base type color. Sometimes when it comes to your weaker base can have something of either a purple or blue color. And just to show you what a neutral substance is going to look like, we're going to see what happens when we add this acid-base indicator to tap water. Now, this is tap water, and notice that tap water has very much a clear appearance, and when we add our substance to tap water is going to turn something of a darker blue. Generally, a darker blue means that it's going to be more neutral, whereas a lighter blue indicates a little more in the way of being basic. And then as you move further along the base scale, as something becomes more basic, it's going to turn green or it'll turn yellow in the case of bleach. And bleach is the strongest base that we have on display for this experiment. And as you'll notice, water tends to have something of a lighter blue color. You'll also notice that baking soda has a somewhat more darker blue color. And then you have sugar. It also has a pretty dark blue color. I would say that probably baking soda, among the weaker bases, has the darkest blue color. Water's a little more light blue, indicating neutrality. And then sugar is somewhere between water and baking soda on the base scale. Sugar's more basic than water, but not quite as basic as baking soda. And then finally, we're going to see what happens when we add our acid-base indicator to milk. And you'll notice that while milk does have acid, it also has somewhat of a pink type color, indicating a rather weak acid. And then the hand sanitizer, it appears that the hand sanitizer is very moderately. It's hand sanitizer would be considered neutral, but it might be just maybe mildly on the acid side from what this indicates. But when it comes to these substances, good way to tell something whether it's acid or base based on color is to look at whether or not it happens to be dark red. If it's dark red, it's clearly going to be acid. If it's pink, it's a somewhat weaker acid. And then if the substance happens to be neutral, it's going to be light blue. And as it gets darker blue, it's going to be more basic. And then substance is finally going to be a very strong base if it has a yellow color. Typically, the higher up you go on the base scale, the more a substance is going to shift from blue to green, and then it'll finally get to yellow when we get to the end of the base scale. So basically, these are the 7 substances that we have used, and we've done major testing to see how you can create an easy home test when it comes to acidity or basicity. We hope that you have enjoyed our little presentation, and I am open to any questions.
Thank you.
Okay. I'd like to thank everyone so much for their support.